All right, so you guys just watched the video of speed, velocity, and acceleration to get you guys warmed up for today. Now you have a paper that has this in it. I need you to cut out this big rectangle, just like how I did. And then you're going to cut out on these black lines. So there's going to be 4, well, I guess it's going to be, you're going to cut it in half, just like that. Then you're going to cut this line to that dotted line. And leave that dotted line because that's what you're going to glue on. Okay, so you're going to glue on the back of this dotted line. Let me get my glue. Put glue on this one. So you want them to be able to be flaps. Let's see how big this is. We're going to have to go over our red line a little bit here. So I guess line up the dotted part of your paper with the red line. You have enough room. Just like that. And you're going to do the same thing on the other side. Glue down this end. And then put it like right next to your holes. And I did line them up with the line on the top just to make it a little bit straighter. And it's okay that's separated because you'll need the room anyways. So now these are flaps that you can open just like this. And then you can write underneath here. Oops, some glue. That off. All right. So go ahead, pause the video until you have that all set up, and then we'll start. Okay, so we're going to take some notes underneath these flaps. So we're starting to learn about distance time graphs because when you're calculating motion, you can graph it. The data that you get, you can graph on a graph. So we're going to talk about the most popular one, which is distance time graph. And we're going to take some notes on it. So we're going to do this first flap right here. What is a distance versus time graph? Well, distance versus time is just like how we read over here. So distance time graph. These are also called a speed graph. So we're going to add that on here. Also called a speed graph. Okay, because distance over time is speed. That's how they calculate it. They take the distance divided by the time, and that gives you the speed. So that's basically what these graphs are showing. Okay, so a distance time graph is a graph that shows how the distance of an object changes over time. So we're going to write that on here. So this is a type of graph that shows how the distance of an object changes over time. Okay, so here's your example. So EX stands for example. Okay, so they make a graph like this. So you see a graph. So it's one side of the graph and along the bottom. Then they have all these numbers down here. I'm not doing numbers because we're just showing an example of a graph. Whoop. Okay. So this is the y-axis, and this is the x-axis. And along the y-axis, they show the distance. So I'm just going to put d for distance. And along the x, they put the time. I'm going to put t for time. So that's an example of what the graph kind of looks like. And then the bars that go here, like the line graph that goes here, is what shows you how the distance changes. Okay. So go ahead and pause that if you need to finish writing it. Okay, then we're going to close it up. And on the other side, it says, how is constant speed represented? Well, constant speed was one of our vocabulary words. It's speed that stays the same. It doesn't change. Like you're not going faster than slower. You're staying at the same speed. So if you're going at the same speed, so if you're on the highway and you're driving and you have the cruise control set and you're driving at the same speed the whole time, how would they represent that on the graph? So constant speed is shown by a straight line sloping up the graph. Okay. So I really like to highlight or underline or circle words that will help me remember what that means. So for constant speed, you need to remember it's a straight line sloping up. Straight line sloping up. That will help you remember what it looks like on the graph, because you will see that on one of your quizzes. So here's an example. Okay, here's that graph again. Let me see how I did that one. Here's that graph again. We had distance and time. This is where your numbers would go, but we're not going to put numbers because we're not actually plotting anything. And time is on your x-axis, and your distance is on your y-axis. So it's shown just like this. Straight line sloping up. So like time is going on, time's going by, and your distance is getting larger too. So it's at a constant same speed. All right, so that one shows constant speed. All right, paper's not sticking very good. Glue that down a little bit better. There. All right, now the next one, how is no motion represented? So if the car is stopped and you're plotting it on this distance time graph, what would that look like? So that would look like no motion is shown by a flat horizontal think of the horizon. See the horizon? The horizon's like where the sun sets, or you can see the sun rises and it goes straight across. So that's how you can remember what horizontal means. It means straight across, not up and down. It's by a flat horizontal line on the graph. Okay, so here's your example. So we have our graph again. So our horizontal line, the one going across here, is our x-axis. That's where we show our time. And our vertical up and down line is your y-axis, where you show your distance. Like I said, we don't have any numbers on here because we're not plotting anything really. We're just showing what the lines would look like if they were showing this kind of movement. So no motion is a horizontal straight line, just like that. So time keeps on changing, but the distance does not change. They're staying at whatever this distance is the whole time. Time keeps on going on, but they don't change. So for this one, no motion, horizontal line. Oh, flat horizontal line. That will help you remember that. All right, now, how is acceleration represented? So if you're speeding up, how is that represented on a graph? Okay, acceleration is shown with a curved line. Okay, so here's our example again. Draw our graph again. So on the y-axis, which is vertical, we have our distance on, and you always have to label these axes because you don't know. You got to, like, someone else has to be able to read it. It's like you writing a letter and never crossing any of your T's, then they don't know if it's an L or a T, so it's all confusing. So you always have to label the distance and the time so that you know what you're measuring. So it's shown with a curved line. There you go. So acceleration, curved line. So then if you open all these flaps up, this is what it looks like. So you have what a time distance graph is, what constant speed looks like, what no motion looks like, and what acceleration looks like. Okay, once you have these notes down, then you can close up your science notebook and you are finished for today. Don't forget to have your title and today's date on the top.